Hello and welcome to part 6 of 7 for Electrical Principles and Technologies. James Joule was one of the foundations or the fathers of work on energy. He was one of the ones who said that energy is neither created nor destroyed. It doesn't appear then disappear, but is transformed from one form to another. The total amount of energy in the universe always remains constant. No device is able to be 100% efficient in transforming energy. Most often the energy is lost or dissipated as heat. Mechanical systems also dissipate energy into their surroundings, but not as obviously as the heat loss. Much of the dissipated energy is sound. The efficiency of a device is the ratio of the useful energy that comes out of the device to the total energy that went in. The more input energy converted to output energy, the more efficient the device is. So percent efficiency is equal to joules of useful output divided by joules of input energy multiplied by 100%. Most of the energy transformed in a light bulb is wasted as heat. These are incandescent light bulbs, not the fluorescents that we all use now. 5% is light energy, while 95% is heat energy. Fluorescent light bulbs are 4 times more efficient than incandescent bulbs. Arc discharge lights or street lights are even more efficient. Hybrid gasoline-electric vehicles are more efficient than gas-powered vehicles. By comparing efficiencies of devices, the energy costs and their environmental impact can be determined. Reducing the energy wasted by devices. Devices which have an energy-efficient design are an important consideration for the consumer because these devices use electricity. Energy costs money and it also affects the environment, so reducing energy consumption is a good practice. Limits to efficiency. Electric heater comes very close to being 100% efficient, but some devices which convert electricity to other forms can never be 100% efficient. Some energy is lost or dissipated in a form that is not a useful output. Friction causes thermal energy to be lost or dissipated in many devices. Increasing efficiency. Increasing the efficiency of a device depends on its purpose. The easiest way to increase efficiency in many devices is to reduce friction as much as possible. Insulating a device from heat loss is another practical way to increase efficiency. Using capacitors in electric circuits is also another way to increase efficiency. Examples of efficiency. How efficient is an automobile? In other words, how much of the energy in the gasoline results in kinetic energy or energy of motion of the automobile? 12% if it's well maintained, 8 to 10% if it's not maintained. Of the 20 gallons of gasoline you put in your car, how much actually moves the car to your destination? Somewhere between 1.6 and 2.4 gallons. The rest is transformed into waste, heat, and noise. How efficient is a coal-fired power plant? It's about 30 to 40% efficient through a steam turbine. How efficient is an hydroelectric plant? It's about 80% efficient because there is no steam conversion involved. How efficient is a nuclear power plant? The nuclear reaction is 90% efficient. However, the same combustion process, steam turbines, is used to generate electricity as the coal-fired power plant, so the net efficiency is about 30 to 40%. How efficient is the human body? Conversions of energy in the food to muscular movement and other kinds of work is about 20% efficient. Electrical energy sources. The burning of fossil fuels, such as oil, coal, or natural gas, generates approximately 65% of the electrical power that we use. Coal is mined, crushed into powder, blown into a combustion chamber, and burned to release heat. This heat boils water and superheats the resulting steam to a high temperature and pressure, which then turns a turbine. The turbine shaft rotates large electromagnetic coils in the generator to produce electricity. In a nuclear reactor, atoms of a heavy element, usually uranium, are split in the form of nuclear fission in a chain reaction, which releases an enormous amount of energy. Heat from the Earth's core can also be used to generate electricity. This geothermal energy, or hot water and steam, is channeled through pipes to drive turbines, connected to generators which produce the electricity. Biomass is another type of fuel used to generate electricity. The gases produced from the decomposition of garbage in landfills can be used as fuel for steam-driven generators. Electrical energy sources. Waste heat from many industrial processes are used to produce steam-generated electrical power. In terms of cogeneration, the generation of electricity from any fuel source is not energy efficient. About 70% of the energy becomes unavailable during the generation of electricity. Cogeneration plants take unavailable energy and convert it to available energy. Unavailable energy can have many forms, such as heat in excess steam generated by the steam turbines, or wood and biomass byproducts of paper mills or lumber companies, or the use of purified wastewater for steam from any plant. Companies large enough to run their own power plant make the best use of cogeneration. Electrical energy sources. Using water to generate electricity. Hydroelectric power plants generate 20% of the world's electricity. Gravitational energy is transformed into electrical energy. So you have the water here in a higher position than the water here, which causes the turbines to spin and creates power.